This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
This is Nate Black for Software Engineering Radio. I'm joined today by Peter Zaitsev. Peter is the CEO of Percona, a company with deep expertise in open source databases. Peter was an early employee at MySQL AB, eventually leading the company's high performance group. He co-founded Percona and assumed the role of CEO in 2006. Peter is co-author of High Performance MySQL, Optimization, Backups, and Replication. Peter, welcome to Software Engineering Radio.
Thank you.
Peter, there are so many databases out there and more being created all the time. So in this episode, we wanted to cover first, how many databases do you need in a new application? And second, how to go about choosing. So could you please tell us why choosing an open source database is a difficult problem?
Yeah, well, first I would say it's not about the open source database. It is about open source databases, right? If there may be more than one for your application. I think we had this kind of an interesting pivot recently where we had seen kind of a lot of consolidation where you would get decade ago, for example, we would look into some very small number of leading databases, right? You would look at either Oracle or MySQL when it comes to the open source databases, right? And now the trend has been changing where we have a lot of databases which are really purpose built. Right, and so you may well need more than one database to choose to use in your application.
Yeah, we had a few episodes that referenced this development. One was Michael Stonebreaker talking about VoltDB, and he referenced a paper he wrote in 2006 called "The Era of One-Size Databases is Over," or "The Era of One-Size-Fits-All Databases is over."
Yes, that's right.
And since then, we've also covered multimodal databases and polyglot persistence.
Mm-hmm.
Is what you're talking about related to those topics?
Yes, yeah. I think if there are multiple trends which are going on right now, right? So, and let me maybe talk a little bit about that. So, from one standpoint, one of the general software engineering trend, right, or at least one of the patterns we see is the microservices. And what is interesting about microservices is that makes services often, in many cases, own the data and provide the external API on access to that, right? And different microservices may choose the different database technologies which are best suited for their needs, right? So, for example, your microservice responsible for search may use Elastic, while your microservice which is responsible for your order tracking and delivery, right, may use some traditional relational database such as MySQL, right? That is one trend. Another interesting trend is, of course, the rise of the cloud, where in the past it was really hard to scale the number of databases because you would need so much experience in-house to operate and manage those. Now, with rise of the cloud and database as a service pattern, then it makes it very easy for developers to spin up in the cloud their database instances, right? They want, and there is very little friction for you using both MySQL, MongoDB, Elastic, and Redis all in the same application.
Is this just due to it being easier to provision the hardware, or in this case, virtual hardware, or are there other trends that are causing the cost of operations to go down?
No, it's not just about the hardware, and I think the hardware itself is really minimal here, right? When we saw the shift from, well, let's say your kind of conventional data center to the cloud, right, and you have a services as Amazon EC2 and EBS came out, right? It was relatively easy to automate deployment of your hardware and services at those days, right? But the databases are particular kind of technologies, right? They are very important for your applications. If they die badly, they lose all your data, right? And if you don't have your data, well, chances are you don't have your business, right? So they're not. You cannot have like such a relaxed approach, right, to make it to managing the database as you may with your web service, right? Which if it dies, probably nothing happens, right? Our web services, the web service can take over, right? So real change here happened when the database as a service technologies such as the Amazon RDS or Aurora, right? Or even more proprietary technologies as DynamoDB became available, right? Because those technologies, they kind of manage themselves in a sense of if you get this kind of service, it provides you high availability, right? It takes care of your backups, at least in some way, and so on and so forth, right? So as an engineer, as developer, you don't really need to take care of all that messy operations you would still need to do if you just deploy your database on the EC2 environment, right, on your own.
This question was originally, I was thinking about the risk of lock-in to a particular database technology, but that seems to potentially extend to these database as a service situations. Is lock-in a big risk?
Oh yeah. No, of course it is. No, of course it is. It is a big risk with lock-in, right? And this is why, from my standpoint, if you are choosing the databases, everything being equal, you are better off to choose the open source database, right? Or a set of open source databases. Of course, cloud vendors make it very seductive to get on their database as a service offering because they promise so much simplicity, ease of use, and so on and so forth, which does, of course, come with a huge vendor lock-in because a lot of those services are desi- designed to be like as a famous Hotel California, right? Where it's very easy to check in, but it's very hard to check out. All of them, of course, promise compatibility with open source database systems, but this is a one-way compatibility. Amazon makes it very easy for you to move from MySQL to Amazon Aurora with MySQL compatibility, but they also make it much harder to move out, right? Or wherever that is due to the scalability, right? Or wherever some other additional features which they hope you would rely on, right? So yes, I would say that vendor lock-in is a concern.
I'd like to come back to that later when we talk about different open source licenses. I think this is in a way related, but first I want to cover the rest of the roadmap, or I guess these are more high level questions. What's the situation where the choice of the database is really important and we need to care about it a lot versus situations where it doesn't matter?
Well, I think there are multiple angles to that. Right? And if you look at the choices where database is more important, of course, we are speaking about the applications which are more complicated, which are more mission critical, which are large scale. So, for example, the efficiency, in this case, becomes very important. But I think it's also important just in a different way when you are starting to build your application and it's kind of small and easy. It just goes through the different thought process, right? So, for example, if you are developer and you are just trying to build some small application, what database you should choose? Well, chances are that is a database you already know, and that is a database you can build that application with, right? Which would be very different from the choice some Fortune 500 enterprise is doing or making commitment, right, for the next decade, right, to roll out for a whole enterprise.
Okay, so it comes down to expertise and what you know. I think that you're echoing what was said in the Polyglot Persistence episode, which is essentially go first with your expertise or what you're comfortable with, and then have some kind of migration path forward.
Well, I would say this is right. You want to choose what you are comfortable with, right? Hopefully, as an engineer, you have experience, so you understand where you are trying to fit their what is called like a square peg in a round hole, right? Because nothing good good is going to come out from that, right? Less mature, less experienced engineering, sometimes they don't have that, and they may have huge surprises. Then they run into some problems with database. For example, using MySQL as a database, and you start with an application, then you need to have some reporting functionality, and then, bam, surprise, MySQL doesn't really run the analytical queries very fast. Somebody who has experience, deep experience, right, or even medium level experience of MySQL would know that. Somebody who doesn't, that they want, and they may actually think it would be great if I would know about that in advance, so I would have designed my system different.
Great. That leads to the next section where I wanted to talk about the application data and storage model of your application. So, when we did the show on multimodal databases, we talked about finding the data model that fits your usage pattern. And that episode actually talked a lot in detail about different data models and their suitability for various features. Could you talk a little bit about that to give listeners an idea about some specific open source databases and how they map to data models or use cases that fit really well with the way that data model or storage model operates?
Yes, so, sure. I think when you look about a data model, there are kind of two different layers here, right? You may want to think about. One is what your logical model, right? That is how you developer operate with data. The other is more of a physical model. That's how a database engine stores that, and that can be important because what is going to be able to do fast and what's not will depend on that. So if you look at the logical model, some of the most popular models right now would be either your relational database model, right? Such when you have SQL databases, they follow that model. And the great thing about this model, is very expressive. Like literally all kind of applications has been built on that model, right? But at the same time, that requires a lot of thought and design in advance. The other model, which has been raising more recently, is the document model, in which case you do not have to do such an extensive database design as a relational model. Often your queries can be more complicated and easier to understand. It's also often kind of more, I would say, more similar to how you present the data in the modern applications, right? So, for example, if you are front-end developers, your chances are using JavaScript and have been working with the JSON data a lot, right? It's the data structured as a JSON objects. Guess what? You can get those objects pushed directly in the document store database, not so much into relational databases, and you can have the queries, convenient queries on them, right, in a document store database. The third one, which I think is very popular, is also a very simple key value databases, right? That is also very simple to understand, and they have been used for years for things like caching and similar simple applications. Now, this is, of course, not an extensive list, right? You have also the graph databases, right, and other data structures, right? For example, a very popular database called Redis. It offers you something like maybe 10 or more different data structures which you can use for different data models. So that is what I would say from the front end or your logical data structure. Now, if you look at the more physical concepts, right, then in this case you have, I think, a couple of interesting dimensions which are happening so far. One is your database, which are primarily designed for a data store on disk, right? Another, there are also in-memory databases, right? An in-memory database can often do some special optimization on the data access patterns when you can serve the data really, really fast, but then obviously amount of data you can store in memory is limited, right? Now, the other difference you would see for relational databases, you also have things like row store versus column store, right? And this typically seen as wherever this database engine is designed for your analytical applications, right? Running some, complicated queries which crunch through millions, billions, right, or even trillions of rows, versus your more online transactional applications, which typically run simple queries which, so scan or modify maybe hundreds, or thousands of rows, right? They have a different, physical storage structures, right, which are designed for those two different use cases.
In order to get started in choosing a database or databases, then I would have to have some kind of idea about the what you call the logical model and what kind of logical model was appropriate for my application. And then I would have to know what's the set of open source databases that's in that space. So can you walk through a little bit the decision process, or how could I inform myself better about that decision?
Well, one thing I would suggest first, right, is especially when it comes to open source, it is better to travel the road well traveled, right, or use the popular open source database technologies, right, because that is where there is a lot of experiences. You will find books, you'll find forums, you'll find local user group support, right, and if you stuck, it is very easy to get help. Right, so from my standpoint, you can go ahead and look at number of lists of the top open source database technologies, right? You can use, DB engines, for example, is a very popular kind of this benchmark of popularity of different open source data, not just open source, all databases. You can also look at something like Stack Overflow Developer Survey. They also talk well about what databases are popular among different among developers, right? Which I think is a great way to understand where the traction is and where the world is going, right? And in my opinion, you want to stick to the top 10 database technologies unless you really, really need something different. You have a very strong reason to go with that new and exotic database technology, which will just give you that 10x advantage, right? So that is, I think, a most important choice out there. Now, and if you set that as a baseline, then there are not as many kind of really choices out there, right? Because if you think about the, let's say, document store, well, there is a MongoDB, which is by far the largest. There is also a Couchbase coming up, or you can also use doc store functionality provided by MySQL doc store, right, or use JSON store in Postgres, right, which is a little bit less convenient, but you can still use that, right? Relational databases, you have MySQL and Postgres. These are, by far the most popular kind of traditional transactional open source databases, right? So I think that's how it goes.
Does Cassandra also fit into that list?
Yes, that's right. Yeah. Cassandra is obviously also in that list, right? But I think Cassandra is interesting, right? Because when people think about Cassandra, I don't think you think about that as a technology which has the easiest to use the developer interface. But it's really at the same time very well designed for the large scale multiple data center application, right? if you want to build an application where the whole world is your playground, then Cassandra is one of the technologies you should surely look at.
Perhaps I could say, as an ambitious developer, I want the world to be my playground. So why shouldn't I then just always choose Cassandra?
Well, you know what? Because there is no free lunch, right? That is, I think, is a very interesting observation from my side, right? I mean, if you look at any technology company out there, right? Obviously, they promote their technology, right, and they want to explain us, why it makes sense and point and focus the discussion point to things where it has advantages, right? But at the same time, when you make decisions, it's always kind of benefits and drawbacks, right? In this case, there is no absolute silver bullet engineering, and some solution just has it all, right? I mean, and I think that is, at least for me, that is the first question I ask, right? If somebody comes to me and sell me their wonderful technology, right, and I go through all the benefits and say, okay, well, tell me when you suck, because that is what I'm interested. And if you say they're perfect, absolutely for everything, then there is that's obviously not reality, right? I will know what they're trying to mislead me. So yes, when I speak about the Cassandra, right, as I mentioned, that is the technology which you can run across multiple data centers, right? And really be very successful with writing in a multiple data center, data being automatically reconciled for you, and so on and so forth. But that means you have to work with a much more complicated data environment with eventual consistency, right? It's much easier for developers to say, hey, you know what, my data is simply consistent. I read the data, the millisecond rate, I write the data, sorry, right, and then millisecond later I read the data and I have that correct value out there. It's much more complicated to reconcile saying, well, I have a modification out there, but it may not make it to some other, data center location over time, right? And then it also goes into the flexibility of schema and so on and so forth. Now, I think to what you make the sense, right, is my advice to developers would be to really not have that gigantomania, right, if you will. Right. I mean, I see so many people listening to those, let's say, talks about how Facebook built their environment and saying, oh, that is exactly what to do. And I want to say, no, that is exactly what you shouldn't do. Because, it took them many years and billions of dollars of investment to get to that infrastructure, right? If you want to start, then then you want to probably to start looking at what Facebook has been doing when they started, but just map it at the new technology landscape. And this is focus on simplicity and productivity first and foremost.
It sounds like there's a spectrum of flexibility in the technology in a sense. You talked about document stores
Mm-hmm.
and how they give you flexibility in terms of the schema definition. And then maybe relational databases would be, I think, somewhere in the middle because they don't necessarily require you to know your access pattern in advance. You can do things like define secondary indexes later. Whereas I think a technology like Cassandra requires you to know, in a sense, your access pattern and design your keys that you're going to use to access that data in advance before you start putting data into the database. So that would put it even further to the side of the spectrum where you need to plan.
That's right. Now, right, you need to plan a lot more with Cassandra. So document database such as MongoDB, they also support secondary indexes, right? But they do have a relatively limited support for the power of things like joins and subqueries, what you can do very easily, right, with SQL. Right. And then we spoke about this productivity, right? I think what is very important to know here is what the productivity is also very much in the eye of the beholder, right? Because I find a lot of developers which know SQL pretty well, right? And they say, hey, you know what, I can get so productive with SQL fast. At the same time, if you have the other developers which has been bred on JavaScript, right, and they haven't are not familiar with SQL and the relational data model, for them it is weird. It's inconvenient, and it's hard for them to be productive at faster.
Is relational underrated in the current environment? It seems to be getting a bad rap.
This is kind of interesting, right? I believe every new generation, right? And I think in our development engineering environment, generations are, every think about like 5 years, right? Not 20 years old, right? They want to do something new, right? They want to invest something new and exciting, right? And relational databases, they have that wrap of something old. But even more, I think the problem with relational database, what they had that reputation of being not scalable, right? Because if you look at the first generation of scalable systems, right, would be as Cassandra or as MongoDB, there you have to give up a lot of your relational database properties, right, including like ACID consistency, and so on and so forth, to achieve that kind of scalability to hundreds, many thousands of nodes, right? And for the new generation, then they say, hey, you know what? We do not want to change technology or rethink technology if we really have to scale to hundreds of database nodes. Those technologies, right, are very attractive to them, right? Now, this is changing, and you may have heard a term called new SQL, right? That is have a databases which are as featureful as your conventional relational database, right? But which are as scalable as a database as MongoDB or Cassandra, right? That is what that name typically implies, right? And I think that is what is going on more recently on the market, right? And I think that's why relational databases actually often get in the second look.
Okay, but does that apply to Postgres and MySQL, or maybe things in the top 10, or is this something that's still kind of on the horizon?
Well, kind of yes and no, right? So if you look at bare bones MySQL or Postgres, these are single node database systems, right? They're designed to run a database on the single server. You can often scale your reads by using replication, right? You can also deploy manual sharding, like pretty much every large scale MySQL user, as Facebook, right, has done, right? But it's kind of it's painful, right? At the same time, we have the technologies which protocol compatible coming up, right? So, for example, you may have heard about CockroachDB, which is PostgreSQL protocol compatible database, which is scalable across large number of nodes. There is also TiDB database, which is MySQL protocol compatible, right, and also open source, but which is also scalable. Also, in both technologies, there are some add-ons, right? You can think about them as a high level, maybe some sort of proxy, which makes them highly scalable. So, for example, for Postgres, there was technology called like Citus from Citus Data, which would allow you to scale PostgreSQL conveniently, and that actually was acquired by Microsoft just a couple of weeks ago, right? As I think a validation of that technology success and traction. For MySQL, we have technology called VTES, which is something which was born in YouTube, in Google, and now deployed also by number of successful companies such as Slack and I think I forget, Stripe or Square, or one of those two, right? Which also really give you their properties of NoSQL database while having your foundational storage level as MySQL or Postgres.
DigitalOcean is the easiest cloud platform to deploy, manage, and scale applications of any size, removing infrastructure friction and providing predictability so developers and their teams can deploy faster and focus on building software that customers love. DigitalOcean stands out from the crowd due to its simplicity, high performance, and no billing surprises. Join a community of over 3.5 million developers on DigitalOcean. Sign up with a free $100 infrastructure credit at do.co/SERadio.
it sounds like these technologies, these add-on technologies, as you described them, have something to do with operations, but then you've also talked about different storage engines which are compatible with, for instance, MySQL. I might be able to replace the default storage engine with something that's based on log structured merge tree. I think you mentioned. So are these two different things? Are they the same thing? Could you please explain that?
Yeah, I mean, these are different things. That's what we are talking about. So, what I talk about with sharding, one of the great things or great challenges for scaling your single server database to a multiple server is something which is called sharding, right? And which is really bane of developers' existence. Because what that means now, instead of just connecting to a single database and running your query, which can join as many tables as you like, and so on. So if you have to somehow manually go to multiple databases, fetch the data which is stored on them, and then somehow integrate that in your application, right? That is what the manual sharding is at its worst, right? And if you look at the technologies what I mentioned, such as Vitess, they can say, hey, you don't have to do that. We provide this top layer which does that all for you. You just run your query as it's conventional, and we spread it across multiple nodes, retrieve a result set, merge them, do whatever for you, as well as handle what you mentioned as operational pains, right? Which also does exist in those large scale environments, right? Now, the second question, what you mentioned about, okay, the storage engine, right? Especially in the MySQL case, we do have multiple storage engines which have different properties and which are responsible how your data is being stored and processed, right? The most popular MySQL storage engine is called InnoDB, and that is pretty conventional storage engine. In fact, somebody who implemented that years ago really looked at what Oracle does, right, and pretty much implemented a lot of similar ideas in an open source environment. Now, the other storage engine which is available for MySQL is called MyRocks. It's based on RocksDB, which is technology which was created in Facebook, where they wanted the storage engine which is more efficient for their workloads, right? And that is something which you can use with MySQL, right, and get the better performance, right, or in many cases reduce the costs by choosing that storage engine. As you mentioned, it is based on log structured merge trees instead of B trees, which InnoDB is based on. And log structured merge trees, they handle writes, especially inserts, much more efficiently than in InnoDB and other B tree based storage engines.
Okay. So sounds like a combination of factors that go into, well, there are a few different parameters it seems like that are moving. One is you said these add-on technologies that make both operations but also development easier because I don't have to think about a lot of the underlying issues of manual sharding, targeting a specific node, but then also there are these other decisions. So it, I'm not sure we're getting closer to a understanding of how to choose the database. I'm almost getting more confused.
Okay, yeah. Well, that is that's right. That's right. Well, look, I mean, I think you go deeper and deeper, right? And this is like, peeling an onion, as a Shrek would say, right? I mean, you see just more layers and layers out there. Now the good thing in this case, right? What a lot of those problems they really happen at large scale, right? And that is, I think, what is very important to understand is what the questions you need to answer on the small scale and the large scale, right? They're entirely different. Right. So, for example, if you are not operating on the Facebook scale, you can use standard built-in InnoDB storage engine, and you will be just absolutely fine. That's probably even better choice for you because, as I mentioned, you want to stay with the crowds, right? And InnoDB is by far the more popular storage engine than MyRoxy, right? In this case, so yes, I mean, if you go back and say, well, I am developer, right? I'm trying maybe starting my new startup. Maybe I'm trying to build application right in my current company, and I want to see look at the databases. What you want to choose, right? In this case, I would start a question if you have your own any preference, right? If you are familiar with that database and have a preference, that is a very good shortcut. And in this case, I would evaluate wherever your database of choice is reasonable for the application you are trying to build, right? Because, for example, if you are, building the application for banking or e-commerce, right, and your database technology doesn't which you're comfortable with doesn't support ACID transactions, well, maybe you need to go ahead and learn the new technology, right? That would be my first initial step, right? And as the time goes, right, what often happens in this case, if you look at as technology develops, in many cases you start with single technology, but then you chop certain things away and introduce some more technologies to the mix as you either certain features of your complexity becomes more complicated, or if it just become much more you need much more scale.
Okay, this gets to the topic of polyglot persistence. So we would, at a certain level of scale, we'll take the hit of adding some additional complexity by adding a new database technology to the system. How do you approach that? How do you approach that problem? What do you recommend for people to do? How do you know when it's time to add a new technology versus try some more advanced techniques to get your existing technology to scale?
Well, I think that is a very good question, right? So I think the first question I would ask, right, and often that is sort of like a management is to ask that question is, okay, what is the reason that new technology is being introduced? Because in many cases, what I see the reason is, hey, I want to play with cool toys, right? Or hey, I want to get this technology. It will look good at my resume, right? Rather than actual, great technical reasons to do that. And look, and that may be okay, right? Maybe as a choice, you can say, well, you know what? I want to retain that top talent I have, and I have to give them toys to play sometime, right? But then you also have to understand the risks of such a decision. And let me tell you a story about this topic. So I remember a few years ago, I was visiting a customer, and we were talking about some log storage. And we thought, well, you know what? We store logs in MySQL, but everybody knows MySQL is a bad technology for storing logs. There is this Cassandra technology, which is based on LSM trees, which are optimized, right? Okay, well, I would ask him, okay, how much log files do you store? I would think maybe that's a terabyte or more. He'll say, well, that's about 10,000 lines a day. Well, I would tell him what at this point, 10,000 times a day, it doesn't really matter, right? You can store it in MySQL, you can store them, in Cassandra, right? You can even store them in the flat files and grab them. It will still, from performance standpoint, would not really matter. So then, as it happens with consulting, right? You just give your advice and leave. And I visit them again, maybe kind of 6 months later, and we look at some performance problem. And I was asking, okay, can I take a look at your logs? And they would look at me and say, well, we actually have a problem. We store the logs in Cassandra, and that guy who managed that Cassandra, he recently left. And we don't have anybody else with Cassandra experience, so we don't really know how to get him out, right? So this case is, of course, maybe kind of trivial, but that gives a good idea is as you introduce more technologies to the mix, you have to make sure you have either somebody in the team or a vendor relationship so you can maintain them on the scale that you need to do, right? Which does introduce more complexity, more cost in your environment as well.
That's great. That gets into questions that are, I think, less obvious things to consider.
Yeah. Let me actually say something else right about this case. So I want to also say at the same time, you should not do things which are, stupid or ugly, right? I remember at some time we would do such a, crazy stuff with MySQL to try to make it full text search work, right? For example, which doesn't scale well at all, right? It is much better choice in this case to say, hey, you know what? This technology just doesn't fit. Let us go ahead and use Elastic, right? And in many cases, the challenge in this case can be what your current vendor or your team may be resistant to introducing some of those additional technology, right? In this case, for all kind of reasons, right? And this, I think, is very important for the managers, right, to look and say, well, you know what, that doesn't smell right. That is, it really looks like they're using a hammer to get the screws into a wall, right? And while we may make it happen if we hit really, really hard, right, that doesn't look right to me, right? And then that is a very good reason to consider other technologies to use.
Are there situations where you want to also simplify the system and reduce technology? Because clearly there's a cost, as you mentioned, to having expertise and then also operational costs.
Yes, of course. In you don't want to use too many technologies, right? In this case, much more than your application requires, and in some cases, you may want to reduce their number. And here, I think, a couple of interesting trends which going on, right? Like I think their multimodal databases. That is, I think, one of their important play to say, hey, you know what? Instead of having that complexity of all various technologies, just use one technology which does it all for you. It's yet to see, right, from my standpoint, how many people who already adopted a variety of technologies which move to this approach. But I think that is a very appealing for people who know they have a variable data model needs, right? And they would want to standardize on one technology instead of many. But there is another interesting trend going on, which is about technologies learning from each other and kind of copying each other features in some extent. So let me give you example. In MySQL, there is a doc store interface now available, which allows you to pretty much have MongoDB-like experience in terms of storing your data and in terms of retrieving it right from a server. At the same time, if you look at MongoDB for the years, they have introduced something similar to the join, right, to be able to have at least some basic support, right, for SQL-like queries. In terms of Cassandra, we have a language which is called CQL, right, which is not the same, but some that's similar to a SQL language, right, which is the core of your productivity of relational databases. Right, so that is also a trend which is happening. Well, and of course, Postgres, right? Postgres also have a lot of features added over last years in terms of a JSON store, right? Storing the JSON documents, processing, retrieving them effectively.
Okay, what does this tell us in terms of how to make our decision? Does it mean that the choice doesn't matter as much because we can go, in a sense, from, since the features are blending together as MySQL adopts some MongoDB-like features, or what does it tell you?
Well, from my standpoint, I think the choice still matters, right? Because while there is certain exchange of features, right, or the cross pollination, right, I think is a good word to use here, happens, it is still far from complete, right? For example, I mentioned SQL, right, with Cassandra's language. It's good enough for some basic SQL-like features, but that's nowhere as powerful as a full-blown SQL implementation. Obviously, we talk about the MySQL being a doc store. Yes, it has allows you to use MySQL and some simple applications, but it has not as a broad support in the drivers and the frameworks, right? Or it also doesn't have the same scalability MongoDB offers, right? What I say in this case is what there is work going on in the open source ecosystem and beyond is to simplify those choices, right? Like you mentioned the paper of Michael Stonebreaker, right? In terms of the one database fits all era is over, and indeed over the last decade we had a huge number of open source databases, and not just open source, special purpose database in general created. But this kind of has a pendulum; it goes back and forth, right? Now we are looking at that and say, "Wow, there are so much variety, there is so much choices. Wouldn't it be fantastic if my database could do a lot of it, if not all, so I don't have to run so many technologies, right?" And there is a lot of movement in that direction.
Software Engineering Radio, episode 199, Michael Stonebreaker. He breaks it into three parts: OLTP, which is kind of what relational database technology targets; data warehousing, which I think people can think of as when you have lots and lots of data and you want to run analytics on the data. And then he puts these NoSQL technologies and pretty much everything else into like a third category. And his prediction was that eventually a lot of the NoSQL people will be moving more towards having SQL-like features, whether that's high-level language for accessing the data, whether that's retrofitting some type of transaction capability, and essentially that the people, developers wanted those features. Is that something that you've seen?
I agree in terms of cross-pollination, which is happening, right? And in many cases, I would say though, from NoSQL engines, we are seeing what the SQL-like features are being added, but they are not being replaced. And a lot of that has to deal with the engagement with developers, right? Now, if you would take a look at that developer writing the code, for example, in JavaScript, right, or Python, and if you would see them accessing MongoDB versus MySQL or Postgres, is MongoDB looks so natural, right? In this case, you really pretty much see that as an extension of your language. You access it almost like you would access your own local data structure, right? Compared with SQL, you actually have to write, you know, SQL query, right? If you're not relying on ORM framework, which is going to do that for you, right? And I don't think they're going to just give it up, right? Because that is so powerful, so convenient for simple applications. But at the same time, for complicated data retrieval needs, the SQL and SQL derivatives proved itself to be a very powerful language.
Okay, so it gets back to where you are in the development lifecycle and what your needs are in terms of scalability.
That's right. Now, and let me say something else, right? If you look at this kind of big choice, which often happens, doc store, right, or document model versus relational model, I think a couple of things which are important here. In many cases, when you look at the document store, it's also often called schemaless, right? And that is often what developers love, because that means I don't have to think in advance what columns I'm going to have, right? Or even more complicated structure, what kind of joints I have to write, right? I can just evolve my schema as I like. I'm writing the code. I can say, oh, I want to store the size here, right? Boom, added the attribute to my data structure, and here it goes into the database, right? Now, and that is very good for productivity of today, right? At the same time, in reality, there is always schema, right? It just it may not be in a database, it may be in your application. And as the time goes, many developers find what maintaining the schema in your application is actually pretty painful, right? If over here you have, created 40 different variants of that schema, and you have all the different objects with all those data structures stored in the database, it is very hard and painful to reliably process all of that in your application, right? And that is when people say, well, you know what, that is good. We had a restriction of that relational database, which kept us more disciplined, right? So what is happening here from one standpoint is the NoSQL databases, they target that problem, of course. In recent MongoDB versions, you would have the ability to validate your documents has been added exactly to reduce that free-for-all approach, right? In this case, but then from the other side, you also may see some of the questions. Okay, how do the question what there may be there is value in more thought out schema design which relational database enforces, where you may lose of those kind of a first day productivity somewhat, but then you reduce your pain so over a long period of time.
What exactly is the trade-off then? Is it simply that when I'm using a relational database with a schema, I'm thinking about schema evolution and schema migration more in advance, or is there really like some other cost or benefit involved?
Yes, there is another, I think, an important cost and benefit in this case. And I think that is the question. If you think about your schema, is that schema which is shared by the multiple of applications, or is it belongs to the single application, right? And let me give you maybe an example. So imagine you have their mobile game, right? And you have a characters. Those characters have probably a lot of properties, right? Maybe have some items in their backpack and so on and so forth, right? But what is the interesting thing about this data? It's only interpreted and processed by the single application. In this case, the doc store is absolutely fantastic because I can use any kind of complexity for my, for example, character or whatever object, right? And then I can very conveniently store and retrieve that from a database. Now, let's say compare that to your e-commerce application. Then I may have, let's say, some sort of, orders database, right? Like a kind of classical relationship example, which may be used by a lot of different applications. Right, one application forward facing to users when they're buying this stuff, and there is another application which manages delivery of those things, and there is a third one which uses the same database which shows the managers which goods are being sold well and which are not, right? In this case, relational database is often much more convenient, right? Because that saves us from having to manage the schema evolution in all three different applications.
Is it because the schema evolution is something that's structural in the database versus something that's just logical in the application layer?
That's right, yes. Because in this case, if I just simply have that game and I change one piece of code which says, "Hey, now I added a couple of more things here, a couple of more properties," and that's it, right? It stores the new objects. It's in a new format. It's processes the objects in the old and new format. That's easy. If I have 5 applications, right, and then I have to teach every single of those 5 applications now to deal with objects of a different kinds of a different structure, right? Which is complicated, but even more so, it is error prone, right? Remember, database is something which is often very critical for your business, right? In this case, and some mistakes, right, may cost you many thousands or even millions and more dollars, right? In this case, so you often very for certain applications you very very much about database working correctly, or actually application working correctly with database.
How do I evaluate when a database is mature enough to be used in a critical system?
Again, I would repeat the same thing I said before, right? There is a safety in numbers at large extent, right? I mean, if you know a lot of people have used that database already, right, in the similar circumstances, that increase the probability, right, what you would be successful as well. Or if you run into troubles, you would be able to resolve them, right? But at the same time, of course, if that would be the case, right, then no new databases would come to a picture, right, in this case, and that shows us another path. In many cases, where early adopters they start to deploy those new databases. Sometimes they are smart, right, and they deploy them in less business critical environments where mistakes are okay, right, and downtime doesn't cost a lot of money or people lives, right, and then those databases can get polished. Sometimes that's not the case, right, and we can see somebody doing getting reckless decisions, getting the databases in an environment which is not it's not ready for, right, in this case. I mean, my approach would be to be practical here, but also do not rely just on other people's experience. Often what I found, it would be surprising discovery what certain things which worked for other people do not work for you because you're doing certain things differently, and somehow nobody did it exactly the same way, right, which can cause bugs or performance problems and so on and so forth, right? So the best tool, in my opinion, is at least doing some sort of a proof of concept with a database technology which you think may be good fit, right? And to get a feel how it actually does what is important for you. For some people, things like scalability is important when you want to test that, or efficiency, test that as well. In some cases, it may be, for example, language support, right? If you specifically look at the relational databases, SQL is so powerful, so variable, and no two relational databases support SQL language in exactly the same way, right? So you may want to test what it has, their SQL language features you would like to use, right? Now, I think what is also becomes increasingly important is non-technical properties, right? Especially in the enterprise space, which is asking questions about, well, what about the vendor viability, right? Because hey, we know some of the open source database companies like RethinkDB or Basha, which was company behind technology called React, went under, right? And you don't want to be stuck in situation where your technology has no more commercial support, right? So think about that. Or some other, I would say, operational aspects. Do we have the data at rest encryption, right, or auditing functionality which may be required by the compliance departments in the enterprises for that technology to be able to be used?
This gets into another area that you've talked about and could be important in the decision, and that's the licensing. So we've already said that there are reasons to prefer open source databases, but there's also some nuances around the particular type of open source license. Could you talk about that?
Sure, and I think we look at a very interesting time when it comes to licenses in the open source space, right? I mean, if you look at the traditional open source licenses, they could be put in relatively two buckets, which are most commonly used, right? These would be called permissive licenses and copyleft licenses, right? Permissive license pretty much means you can take a software and customize it, and maybe to, release a commercial version of that if you like, and that's their license behind the technology such as Postgres, right, or the Apache license, how a lot of technology such as Hadoop would be licensed, right? The other set of technologies, or the other type of license is the copyleft. That pretty much means if you are taking using this software, then you have to also stick to the software you release with it to be open source as well, right? The most notable examples in this case are the MySQL, which uses GPL license, and MongoDB, which until recently used a GPL license, right? Which are both so-called the copyleft licenses, right? And why would vendor choose one or another license? If you think about your permissive license, then that really is the best for adoption, because then that means a lot of users, but also other commercial vendors can take your technology and do whatever you want with it, and hence drive an adoption, right? But that have a downside of having more fragmentation potentially, and also from the vendor behind technology to be able to monetize it, right? Which is very important, of course, with a lot of venture-funded modern open source companies, right? Or companies behind the open source technology. Now, here is the challenge. These things, such as simply having a copyleft license, worked well in the times when the software was distributed, right, on compact discs, right, or whatever. Now, in the age of the cloud, that is not good enough, right? For example, MySQL has GPL license, but at the same time, the company which probably makes the most money on MySQL right now, it's not Oracle who owns MySQL, it's Amazon, who has a very popular Amazon RDS and Aurora services, and they're able to do that even though their MySQL is GPL licensed, because they are not really distributing software, right? They're just running modified version of that software themselves, so they can do that according to the GPL license, right? And that brings us that's to the next interesting evolution, right? The number of those venture-funded companies, open source companies, you can say, hey, you know what? We do not want cloud vendors such as Amazon competing with us. We want to do something about that, right? And that do something is typically not in line with the spirit of an open source license, but that is in line of them defending their own commercial interests, right? So what happened in this case is the company Redis, they added what's called the commons clause, which would be better described is I want to make all the money clause to the Apache license, right? Distributing some of the Redis models. MongoDB, they relicense MongoDB in the SSPL license. You also see Confluent, they change the license for certain parts of the Kafka platform, right? So I think that is a very interesting trend, how the open source evolving from just open source, but where that is permissive license or copyleft, to wherever that is to kind of more shades of gray, right, if you will. There are some software which will be truly open source, and other will be, hey, we give you access to the source code, but there are some restrictions about how you can use or modify that software. And obviously, from your standpoint, right, if you want to avoid vendor lock-in, you want maximum freedom, right? You want maximum freedom to be able to support and change that software yourself if you like. You want to hire different vendors, right? In this case, if you don't want to hire it in-house, and not to be bound just by to a single technology vendor for support and other services, right? And in this case, that's why I would encourage everybody to understand, if you are really dealing with open source or with something which is called open source, but it's not really in the spirit of the open source software.
What's a situation you've seen or that you predict would be a problem caused by these changes to the licensing? So, like, I'm thinking about the specific impacts or problems that you've seen.
Well, it's interesting, right? A lot of those things happen very recently, right? So when I mentioned Redis, Confluence, MongoDB, all those have happened in the last 6 months in the year of 2018, right? And if you look at the open source software adoption trends, and that's where most of the impact is likely to be, it often takes months and years to really materialize. What we can say, I think, about the SSPL, right, MongoDB's new license, we can see is what number of entities such as Fedora projects or Debian, they already judge what they do not consider that as an open source license. And due to those reasons, the MongoDB is being removed from Debian, right, from Fedora, and from next version of Red Hat Enterprise Linux, right? Is that going to be immediately causing some loss of user mindshare or adoption? Probably not. Over time of years, it's maybe. Now, what that also made is while it's may prevented Amazon, right, which is obviously a big cloud boogeyman for many open source vendors, it prevented them from releasing MongoDB as a service. But guess what they did? They released the MongoDB compatible database, right, as a service still. And now we are just getting the fragmentation that happen in MongoDB space. And of course, right now this technology is rather simple. It doesn't have all features for MongoDB, but Amazon has a lot of resources, and they show that they can really do a great engineering effort. And in a few years, that's maybe a very mature technology, and pulling both the mind share from MongoDB as well as a business. So that's what we see now. But you know what? I don't know how that's going to play out.
We're almost out of time, so I wanted to give you opportunity to talk about anything else, any other important topics that we didn't cover.
Yeah, I want to go back to the topic we discussed in the start of this conversation, right? And I think that was a very interesting topic, right? About how does cloud impact the open source, right? And what you can see, of course, in this case, there is important impact, right? Where we see a number of users which would traditionally use open source software, they're not quite using open source. They're using open source compatible cloud versions because of convenience, and that's what they care about first and foremost, right? And I think this is, from one extent, is a worrying trend, but from the other extent, I think that is something where we will see some changes in the coming years, right? Like, well, if you remember, right, or maybe read about the mid 90s, right, when internet was born. Actually, open source was still out there, but tools like open source operating system Linux, MySQL, and so on, so there were not really good enough, right? In this case, Sun, Oracle, they're much better, they're much more mature, right? And that's what people use. But then open source technologies, they caught up, right, over time. It's just what they take time to happen. And I see what a lot of similar things happening in the cloud now as well, right? We are seeing a lot of companies coming together, especially behind the Kubernetes effort, right? Which really allows us to write the applications for the cloud conveniently, right? Not just for a single node, and that really allows to create the new generation of applications which are easy to use, same as Amazon RDS, right, or MongoDB Atlas, but which are completely open source, right? And we're just seeing the first time, and there's the first generation of those applications coming up. They're not as mature, but I would expect within next 3 to 5 years, we'll have the new generation of those cloud native open source applications which can give quite a bit of competition to those cloud vendors platforms, right, which require lock-in.
So what's the takeaway for someone who's creating a new application? Are you saying that it's they should just use the cloud provided solution for now and keep their eye on these new technologies, or is it really critical for them to avoid lock-in?
Well, I think the question in this case is, as usually, it depends, right? Because if you are writing a relatively small application, in this case, that using the cloud is a very practical way for you to do. Use what works best now, right? Be practical. Now, if you are the enterprise, right, which has a 10 years planning horizon and which really wants to commit for technologies or for a long term, I know many of those companies are now investing massively in a Kubernetes effort and try to move as many technologies to that technology as possible, because you know what, they already have seen their Amazon cloud bills and they know those are not pretty, right? Or other cloud providers, right? And they want to make sure they maintain and enhance their negotiating power and ability to move their workloads between the clouds.
Great. Glad we covered that. Peter, how can listeners find out more about what you're doing, follow you, and find out more about Percona?
Oh, well, yes, you can find us at www.percona.com, of course. Right, we have a blog which has a lot of wonderful technical information. You can also follow me personally on Twitter, which you probably just include in the links for the podcast.
Yeah, that's right. I'll include a link to your Twitter and blog in the show notes.
Okay, thank you.
Thanks for being on the show, Peter. For Software Engineering Radio, this has been Nate Black. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.